This lesson is on polygons. So what is a polygon? A polygon, the prefix poly means many, and the suffix gon means sides. So a many-sided figure is what a polygon is. And we have different types of polygons we're going to study. Majority of the polygons we often work with are regular. What a regular polygon means is that every side and every angle has an equal measure. So for a triangle, as we've studied before, that would be your equilateral triangle. When we talk about a four-sided figure, that's going to be our square because it's going to have 4 equal sides and 4 right angles. So regular are just, when you think of the ones that fit in like your shapes when you're a little kid, those are your regular shapes. They're just kind of your normal, everything's equal, perfectly symmetrical shapes. We have 2 types of ways to draw a polygon. It can either be concave or convex. So just like in science class, when you talk about a concave mirror, concave dents in, whereas a convex are like these. They kind of almost form a circular type of shape. Because the more sides a polygon has, the more and more it starts to begin looking like a circle. We will work with all convex polygons. Very rarely will you ever see a concave. And then just as we did back when we started triangles, we need to talk about the angles within and the angles outside. So we have interior angles and exterior angles. So interior are the angles within the polygon, exterior are the angles outside of a polygon. Okay? So I've already filled in the first row for a triangle, but let's talk about what each column is in this table. This table is just a start for you to think about all the polygons, and then we're going to go into how do you solve things about the polygons. So for a triangle has 3 sides. We know its name. And of course, number of triangles. Well, because we are going to base all of our information on polygons off of a triangle, that's why that says that a triangle has 1 triangle in it. The sum of the interior angles is always 180 degrees. If we are talking about an equilateral triangle in which all 3 angles are the same, that would mean 180 divided by 3 would tell us that each inside angle is 60. So we would have a 60, 60, 60 triangle. Now, if the inside is 60, if we want to know the exterior angles, interior and exterior angles always sit side by side on a straight line. So these 2 columns should always be supplementary. They should always total 180 degrees. So if the inside is 60, 180 minus 60 gives me 120 on the outside. Well, now, what if we had an exterior angle at each angle? So we had an exterior angle on all 3 vertices. 320 degree angles would be 360. So now let's talk about what happens when we go to a quadrilateral. When we go to a quadrilateral, when I say how many triangles does it have, that means if I were to split it so that no angle is showing up more than once or being split more than one time. In other words, I would not want to have an X because that would create additional angles inside here. So you want to split it into the minimum number of triangles that you can. So a quadrilateral is a 4-sided figure. Now, a lot of people will often say, well, that's a square or that's a rectangle. Those are specific types of quadrilaterals. We want to make sure that you understand that quadrilateral is the parent name for all 4-sided figures. So every quadrilateral can be split into 2 triangles. Since each of those triangles contains 180 degrees, that means the quadrilateral itself, 280 degree objects, or 280 degree triangles, is going to give us 360. If we have 360 inside our quadrilateral, if I were to take that 360 and divide that 360 by the 4 angles within a triangle, I would find that each one of them has to be 90. Well, remembering that each interior angle and each exterior angle have to be side by side on a straight line, they have to be supplementary. If I take 180 minus the 90, I will get 90 degrees for the outside. So that should make sense to you that if you have a quadrilateral, it makes that T shape. If you have a 90 on one side, you have a 90 on the other. And we talked about that. And so now if I have 90 degrees on the outside and I have 1 at each of the corners, 90 times 4, well, that takes me back to 360. So let's do the next shape. So the next shape has 5 sides. A 5-sided figure is called a pentagon. If we take that pentagon and divide it so that we would have 1, 2, 3 triangles. Well, 3 triangles at 180 apiece gives me 540. So we have 180, 180, 180. 380 gives me 540 degrees. So what this means is if you add up all 5 angles in this pentagon, we should get 540 degrees. Well, if all of them total 500, how much should each one individually be if the shape is regular? Remember, this is only for the ones that are regular where everything is equal. So when I divide by 5, I get 108 degrees for the individual each inside angle. Well, if it's 180 on the inside, if I take 180, subtract that 108, obviously I had the answer in my head, I get 72 for the inside angle, or the outside angle. So if it's 108 on the inside, it would be 72 on the outside. And if I have 72 degrees for the outside angle and I have 5 of them, that means I have a total of 360 degrees. And you're going to slowly start to see some patterns emerging. I'm going to do one more, and then we're going to see if you can establish some patterns and fill out the rest of the chart. So a 6-sided figure is called a hexagon. Here's a little joke for you. What did the little boy say when the curse was cured? Hexagon. Haha, the hex that was put on him is all gone. Haha. Okay, anyhow, stupid math joke for you. So when I split this hexagon, I will see I get 1, 2, 3, 4 triangles. 4 triangles at 180 apiece is going to give me 720 degrees. If I have 720 degrees and it's a hexagon with 6 sides, that means it also has 6 angles. So when I divide by 6, I get 120. If the inside's 120, when I take 180 minus the 120, that means the outside has to be 60. And if I have 6 60 degrees, that means I have 360. So some of the patterns I hope that you're starting to see is this last column. Notice it hasn't changed. Well, that's because it won't change. The exterior angles on every polygon is always 360. So you can go ahead and fill that last column out. This particular chart, you can actually work this chart from left to right. You can also work it from right to left. So there are ways to work backwards through this. And we're going to talk about this last row. I know it doesn't have a name, but we'll talk about that in a moment. What other pattern you might see emerging is the number of triangles. We started with 1 triangle, 2 triangle, 3 triangle, 4 triangle, so it's going to count up. And leave that last row blank for a moment. And so now that I know that the number of triangles is counting up, how can I find the sum of the interior angles? Well, when there was 1 triangle was 180. When there were 2 triangles, 2 180s gave me 360. When there was 3 triangles, 3 180s gave me 540. So to find that sum, we're always going to take the number of triangles and multiply it by 180. So why don't you go ahead and fill out that column, and pause your video while you do that, and then we'll do a quick check. So I filled out that second column. Give yourself a quick check to see if you filled it out correctly. You may also notice that as I go from row to row, this is also increasing by 180 degrees, which is what's happening. As I add 1 triangle, I'm adding 180 degrees. So that's another way to look at this chart. Now, this next column, these are the inside angles. So if the sum is given by the column here of the sum of the interior angles, if that's what all of them add to be, and I want to find each one, to find this column, I'm going to take that sum and divide it by the number of angles. Well, the number of angles should also be the number of sides. Number of sides or angles. So I'm going to take that 900 and divide it by 7. Now, this is one of the few that does not come out nice, so I'm going to round it off to be 128.6 degrees. You could round it off to 129. I'm just making it a decimal so that you are aware that it is a decimal. So go ahead and take a minute and divide each of those and find out how big each angle is. So take a minute and check your column there. You probably also ran around the 11-sided figure, and that 11-sided figure also does not come out to be a nice even number. Speaking of these and other ones, let's talk about their names. So the 8-sided is an octagon, the 9-sided is a nonagon, the 10-sided is a decagon. The 11-sided, a lot of books leave out 11 sides. It kind of follows the rules of a foreign language that you take a 10 and add a 1 in front of it. So the prefix un means 1, so it's 1 plus 10, which gives me 11. Dodecagon is 2 plus 10, which gives me 12. There's technically a name for every polygon based off of kind of a mathematical naming system with prefixes and suffixes, but we usually stop naming them after 12. So I have one last column left, and that is the exterior angle. So you have a couple options here for exterior angles. We could either subtract our inside from 180, or you technically could work backwards. And if I know I have 360 degrees, I could divide it by the number of sides, and that would also give me the exterior angle. So take a minute and fill out each of those. So check yourself and make sure that you made correct mathematical calculations. So now let's talk about this bottom row. So this bottom row, you're going to see I don't have a picture there because this is for any size polygon. So I have an n under the number of sides. So n is the variable that we usually use to represent the number of sides. So remember, n stands for the number of sides. When we start naming a polygon that has more than 12 sides, we call it a n-gon. So in other words, if it has 15 sides, we call it a 15-gon. If it has 20 sides, we call it a 20-gon. If it has 30 sides, we call it a 30-gon. And as I mentioned a few minutes ago, that every polygon does have a name. You can Google the list of polygon names, and you can get really crazy names out there for some of them that become really long. I know, for instance, some of my students in the past have enjoyed I believe it's 1,000-sided figure is a chiliagon, but they all do have names. So what these blocks are for is for you to notice the patterns that you had. So what pattern did we have for the number of triangles? So you notice that it was increasing by 1, but what if I say I have 20 sides? How many triangles are in it? Well, without having to count up, can you see a relationship? Well, let's look at how many sides and how many triangles. When it had 3 sides, there was 1 triangle. 4 sides, there was 2. 5 sides, there was 3. 6 sides, there was 4. So hopefully you're seeing a pattern that there's always 2 less triangles than there are sides. So we can always represent that by saying take the number of sides and subtract 2. So to find the number of triangles, you always take the number of sides and subtract 2. Well, how did we then find the sum? Well, we took the number of triangles and multiplied it by 80. So the 180. So the formula we use becomes one that's to find the sum. You take n minus 2, which represents the number of triangles, and you multiply it by 180 degrees. Anytime you do that, that will always give you a sum for the number of degrees in a triangle or in a polygon. So for example, if I have something that is 50 sides, if I take 50 minus 2 and then multiply it by 180, you'll find out that a 50-sided figure has 8,640 degrees within it. So you can do that for any polygon. To find the interior angle, we can find it one of 2 ways. So I'm going to draw a little line across my box here. The first way you can find it is you can take the sum, the previous column, and divide it by the number of sides. That's normally how we do it. We take the sum, which is the n minus 2 times 180, and we divide it by the number of sides. The other way we can find it is if we happen to know the exterior angle, we can take 180 and subtract the exterior angle. And the reverse happens on this side. If we have the interior angle, we can take 180 degrees minus the interior angle, and that will give me the exterior angle. and that's because they're supplementary. And then there's one other way to find the exterior angles. Since all polygons add to 360, if you take 360, divide it by the number of sides, then we can find that exterior angle. So in the next couple pages, you're going to see there are some scenarios of different ways we can ask the questions. They all follow from this bottom row of how we calculated this chart. So this is kind of what I call the everything polygon. So if you know the number of sides and you need to know the sum, that's when we're using that formula n minus 2 times 180. So for instance, if the question said find the sum of the measures of the interior angles of a 14-gon, you would take 14 minus 2, times that by 180, and 14 minus 2 is 12, times that by 180, and you should get 2,160 degrees. You do the 16 and the 20. So for the 16-gon, you would do 14 times 180, which is 2,520. And for the 20-gon, you would do 18 times 180, which is 3,240 degrees. Now, sometimes they're going to give you a picture, and they're going to have a missing value. These are not regular polygons. They are all varying sizes. So what they're asking for is, what's the measure of the missing angle? Well, what you need to know is, how many sides does it have? So this has 1, 2, 3, 4, 5 sides. It also has 1, 2, 3, 4, 5 angles. And so if I have 5 angles, that means I have to be talking about a pentagon. And you can do one of two things. You can either use the chart on the previous side to say, well, what should a pentagon equal? A pentagon should equal 540 degrees. Or if you don't have that chart handy, you say, well, 5 minus 2 means there's 3 triangles times 180 means I have 540 degrees. Well, I know that it has to total 540. Add up what you have. So I have 86, 140, 138, and 59. I've used 423 degrees. So if I subtract the two, 540 minus 423, I find out that I have 117 degrees left for that last angle. So x would have to be 117 degrees. You try the next one. This last one here, be very careful. This is supposed to be a side there. It just doesn't come out very well. It's supposed to be 2 sides because it's 1, 2, 3, 4, 5, 6, 7, 8 angles. So make sure you realize this is an octagon. And this one is a 1, 2, 3, 4, 5, 6. So this is a hexagon. So try finding those 2 missing angles and see what you get. So let's check your answers. For the hexagon, make sure you remember that that box is 90 degrees. Lots of students forget to subtract that 90 out. So it should leave you 150 degrees. And this last one, like I said, it's deceiving. Make sure you realize it's an octagon. So what you have to do is realize I have 2 missing variables. So I have an x and a 2x, which gives me a total of 3 x's. If you add up all the numbers, you have 815 degrees used. So if you take 1,080, subtract that 815, and then you have, I believe it's 265. When you divide it by 3, it doesn't come out nice. It comes out to 88.3 as the missing angle. So now let's talk about some exterior. Same idea. Every polygon, though, instead of using a crazy formula like n minus 2 times 180, every polygon is always 360 degrees on the outside. So if I have these 4 angles, I know they need to total 360 degrees. Find out how much you've used by adding your 65 plus your 106 plus your 78. And you'll find out that you've used 249 of those degrees. When you subtract 360 minus your 249, you have 111 degrees left over. So you try this second one. You should have done, if you're doing the algebra, you would realize that you have 3 x's plus that 162 is how many degrees you've used, equaling 360, for an x value of 66. Okay, the next section here is what happens if you know how many sides and you want to find each interior angle. Well, the most direct way when you have the number of sides is using the formula n minus 2 times 180, find out the sum of how many angles are the sum of all the angles in the figure, and then divide it by the number of sides. So you're going to do the very first thing we did up here, find out the sum, and then we're going to divide it by the number of sides. Now, for an octagon, of course, it's on your chart on the page before, but I don't want to cheat and do that. So you're going to take 8 minus 2 to find the number of triangles, multiply it by 180 to find the sum, and then end up dividing it by 8 sides. And so 8 minus 2 is 6. 6 times 180, the whole thing adds to 1,080, divided by my 8 angles. Each one is 135 degrees. You try the next couple. Okay, this next section, what you are going to be given is you're going to be told how many sides the polygon has, and we want to know what is the measure of the exterior angle. Well, remember that every sum for every polygon is always 360 for the outside angles. So if I take 360, divide it by how many sides they have, I will get the exterior angles. So for a decagon, I'm going to take 360, divide it by 10 sides, and that's going to give me a 36-degree exterior angle. So go ahead and take a minute and do the 360 divided by 13, 20, and 18. So you should have got 27.7, 18, and 20 degrees. The next type of question, and so what you're noticing is we're taking all of the rules from that front, and I'm just showing you the different ways the questions can be asked. You're all still using the same idea that you're looking for the number of triangles, the triangles total 180, and you're dividing by the number of sides. It's just what information are you given? Do you need to work forwards or backwards? So E says, what if I tell you an exterior angle and I want to know how many sides it has? Well, it's the exact reverse of section D. D gave you the sides and asked the angle. Now I'm going to give you the angle and ask you the sides. So to do that, you're going to take 360 and divide it by the angle that's given. So 360 divided by 130. Oh no, I got 2.76. What's the problem? The problem is it didn't come out whole. So can you say a figure has 2.7 sides? You might be saying, sure, why not? It's a number, I'll write it down. The problem is it has to come out to an integer, has to come out to a whole number. So since it doesn't come out to a whole number, we're going to say that's not possible. Now, that's the only time it comes out to not possible is when you get a decimal. If you take 360, divide it by 9, and it comes out to a whole number, then we're good. That's 40 sides. Or you could call it a 40gon. If it has 12, 360 divided by 12, that works. That would be 30 sides. That one works. So it's okay for the angle to be a decimal. It's not okay for the sides to be a decimal. Now, last section here says, what if you know the inside angle and you want to know the number of sides? Well, we know that outsides total 360, but we don't know what insides total unless we know the number of sides. So what we want to do is convert our interior angles to an exterior angle. So this is exterior. I'm saying that backwards. This is interior. You want to take 360 minus 180. I am really jumbling this up. Let me start this again. If you have the inside angle, you want to do its supplement, subtract from 180. That's going to give you the exterior angle. So 180 minus 156 gives me 24 degrees. If the outside's 24 degrees, now we can check 360 divided by 24, and it works. That means it has to have 15 sides. If it has 40 degrees on the inside, you want to take 180 minus that 40. That's going to give you 140 degrees for the outside angles. Now we check if that's possible. 360 divided by 140, comes out to a weird decimal. That's not possible. What about 465? Take a minute, pause, see what you get. And you should get that it does work. It would be 24 sides, because when you take 180 minus 165, you get 15. And when you divide, you get 24 sides. So last scenario. Last scenario is, what if you know the sum? And I want to know how many sides it has. Well, remember that the formula for the sum is n minus 2 times 180. So what you want to do is work that backwards. In order to work that backwards, we're going to divide by the 180, and instead of subtracting, we're going to add 2. So we're going to take 720, divide by 180. That takes me back to the number of triangles, and then I have to add 2 to get to the number of sides, and so that has 6 sides. So that would be a hexagon. For 1980, we're going to divide by 180. That's going to tell me it has 11 triangles. When I add 2, sorry, that was supposed to be a 2, that would be 13 sides. And 2,340, when I take 2,340, divide it by 180, I get 13. When I add 2, that gives me 15 sides. So these are the different scenarios of questions that can be asked about polygons.